For notes number 9, the warm-up, we are asked to find some missing sides of right triangles. So the options that we have so far, if they apply, would be Pythagorean theorem. You have to have two sides of a right triangle in order to use that equation. Option number 2 is if you notice a special right triangle like 45, 45, 90 or 30, 60, 90, you can use the patterns. And then option number 3 would be your trig ratios, which all you need is one side of the right triangle to use the trig ratios. So for number 1, I notice that it's a special right triangle because I see the 30-degree angle there, the 90, and therefore this corner has to be my 60-degree angle. So I'm going to use my chart in order to find the missing variables. However, you could also use your trig ratios in order to find the missing side lengths. So the pattern for 30, 60, 90 right triangles, we used an equilateral triangle and built the picture from there. We found that the 30, 60, 90 had side lengths 1, root 3, and then 2. And then if I look at this picture, I'm going to fill in what's across the 30-degree angle, which is 3. Across the 60 is x, and the hypotenuse is y. I notice that my first column has just numbers, the 1 and the 3, so I could use that to find my scale factor. So we're trying to figure out what we multiply the original side lengths by to get this new triangle. So 1 times what would give you 3? That's easy. My scale factor would be 3. So you're multiplying all originals by 3. So x is the second column. It's 3 times root 3, which is just 3 root 3. And if you want to type that into a calculator to get the decimal form, I would hit 3 times 3 square root equals, and I get 5.2. Y is just 2 times 3, so y is equal to 6. For number 2, I noticed that only one side length is given, so I can't use Pythagorean theorem. It's not a special right triangle because it's a 33-degree reference angle, so I'm going to be using my trig ratios, or SOHCAHTOA, where sine stands for opposite hypotenuse, cosine is adjacent hypotenuse, and tangent is opposite adjacent. So my reference angle is 33 degrees here, so I'm going to label my OH and my A according to the reference angle. Directly across the 33 degrees is my opposite. Since there's a 15 there, I'm going to put my O for opposite. My hypotenuse is always across the 90, and there's a variable there, so this is my hypotenuse. So I'm finished labeling. So what uses an O and an H? That would be sine. Before I continue, it says, how come the value of x cannot be a 12? If I look at my picture, x, what I'm trying to find, is the hypotenuse. That has to be the longest side, and the only other value I have is a 15. So I know that 12 is not reasonable because it has to be larger than 15 since we're trying to find the hypotenuse. So the hypotenuse must be the longest side. Therefore, my value should be larger than 15. All right, so let's use the sine equation. So sine, my reference angle is 33 degrees, and that's equal to opposite, which is 15, and the hypotenuse is x. So to solve this, I put a 1 under the left-hand side and then cross multiply. 1 times 15 is 15, and that's equal to sine of 33 times x is just sine of 33 times x, or x times sine of 33. I still have to isolate x using one last step. The opposite of multiplying by sine of 33 would be dividing both sides by sine of 33. So I'm going to record this in this spot. My answer for x, before I type it in, is 15 divided by sine of 33. So how would I type this in? I would hit 15 divided by 33 sine equals, and I get to the nearest tenth 27.5, which makes sense because it was larger than 15. So for our goal today, for the next couple examples, instead of finding a missing side of a right triangle, we're going to be finding missing angles this time. And so the button on your calculator that you're going to be using is the sine inverse button, or cosine inverse, or tangent inverse, which just means that you're going to have to hit the second button in order to get those buttons on your calculator. So the very first thing we're going to do again is locate the reference angle, which is x, what we're actually trying to find. And then just like the previous notes, we're going to label our O, our H, and our A according to the reference angle. So directly across the reference angle is a 40, so there's my opposite. The hypotenuse is always your longest side across the 90, so 41 is my hypotenuse. So we're complete with labeling. So sine is defined as opposite over hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. So if I look at my picture, I notice there's an O and an H, so that would be the sine equation that I'm going to be using here. So plugging this in, I would have sine, my reference angle, which is x, and that's equal to opposite, which is 40, and then the hypotenuse, which is 41. So technically, once you have this equation, there's nothing to solve. You're not cross multiplying because you can't actually get x alone, because remember, sine, cosine, or tangent always has to have a reference angle attached to it, so you can't detach the x. So technically, you're going to be plugging this into a calculator, and you're actually going to be typing in sine inverse of 40 over 41. Where's the symbol even coming from? If you want to show the mathematical work to actually get x alone, you take the sine inverse of both sides. Whatever you do to one side of the equation, you do to the opposite side. And this is how you technically get x alone. So you're really typing this into the calculator, sine inverse of 40 over 41. So how do you ask the calculator, what is the reference angle when the opposite is a 40 and the hypotenuse is 41? All you're going to do is the following. You're going to type in 40 divided by 41, hit equals. So 40 divided by 41 equals. And then you're going to press second sine. So on your calculator, hit the second button, and then hit sine, which if you're using an iPhone, as soon as you hit the second button, it turns the sine symbol into a sine inverse. So if you hit second sine, don't press equals, you should get 77.3 degrees. So again, to type this in, 40 divided by 41 equals, and then hit second sine, and you should get 77.3 degrees. So for the next two examples here, we're just going to do the exact same thing where we're trying to find the reference angle instead of finding a missing side. So it still starts out the same. Locate your reference angle, which is x, and label your O, your H, your A. So directly across the reference angle is always your opposite side. So 15 is my O. The hypotenuse is always across the 90, which is the 24. So opposite and hypotenuse are labeled in this picture. So sine is opposite over hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. So the equation I'm using would be the sine equation because I have an O and an H labeled. So if I plug in for my picture, I would have sine, the reference angle, which is x, and that's equal to opposite, which is 15, hypotenuse, which is 24. So technically, once you have this equation set up, everything is typing into your calculator. So technically, I'm typing in sine inverse of 15 over 24, but really you just have to worry about how you get your answer. Type this in. So I would hit 15 divided by 24 equals, and then hit second sine, and you should get 38.7 degrees. So again, 15 divided by 24 equals second sine. Make sure you don't hit equals in the very end. You only hit the equal button once to get 38.7 degrees. For the U-Try, go ahead and pause the video and try it on your own and see if you get the same answer. So my reference angle is x, and directly across from that, 25 would be my opposite. So opposite is taken care of. My hypotenuse is always across the 90-degree angle. It's completely blank, so I'm not going to label hypotenuse. Therefore, my adjacent is the 78. So sine is opposite over hypotenuse. Cosine is adjacent hypotenuse. Tangent is opposite adjacent. So in my picture, O and A are labeled, so I'm going to be using the tangent ratio. So plugging in from the picture, I would have tangent, the reference angle is x, and that's equal to the opposite, which is 25, and the adjacent, which is 78. So once you have your equation, again, you're not cross multiplying because you can't isolate the x in that fashion. From here, it's all calculator. So technically in your calculator, you need to know what tangent inverse of 25 over 78 is. In other words, you're asking the calculator, what is the reference angle when tangent would be 25 over 78? So you would type in 25 divided by 78, hit equals, so 25 divided by 78 equals, and then hit second tangent, and you should get 17.8 degrees. All right, for the backside, number 3, all we're doing is finding a missing side of a right triangle. And for these two examples, we're going to be using our trig ratios. So 57 is our reference angle, and labeling 10.8, that would be our opposite side. And directly across the 90 degrees, x is our hypotenuse. So what uses an O and an H? That would be the sine ratio. So let's plug in from the picture. So sine, the reference angle is 57 degrees, and that's equal to the opposite, which is 10.8, over hypotenuse, which is x. Since the right side's a fraction, let's make the left side a fraction, put a 1 under, cross multiply. 1 times 10.8 is 10.8, and that's equal to sine of 57 times x is just sine of 57 times x, or if you want to write the x in front, it's up to you. One last step to isolate the x, divide both sides by sine of 57, and before I type in my fraction, which is here, I'm going to estimate my answer. So if I look at my picture, I'm finding the hypotenuse. It has to be bigger than the 10.8, because that's the only side length given. So an estimate would be larger than 10.8. And again, the reason is we're trying to find the hypotenuse. So to type in our fraction, I would hit 10.8 divided by 57 sine equals, and I get approximately 12.9. All right, for the second example, my reference angle is the 47 degrees. So directly across from that is always my opposite. Since it's completely blank, I'm not going to label that. The hypotenuse is across the 90, so 3 is your hypotenuse, and then the x would be your adjacent. So what uses an A and an H? That would be the cosine ratio. So let's plug in from the picture. So cosine, reference angle is 47, and that's equal to adjacent, which is x, hypotenuse, which is 3. So since the right side's a fraction, make the left side a fraction by putting a 1 under and then cross multiply. 1 times x is x, and that's equal to cosine of 47 times 3. So this is all calculator. Before I type this in, I'm going to look at my picture and give a good estimate. So 3 is the hypotenuse, and I'm finding one of the legs. So my answer has to be less than 3, because 3 has to be the biggest side. So to type this in, 47 cosine times 3 equals, and I get approximately 2.0, or just 2. For number 4, it is multiple choice. So it says in a right triangle ABC, where B is the right angle, you calculated that the sine of A is 5 over 13. Select all that are true. The first thing I'm going to do is I'm going to draw this right triangle. it tells me what to label the right angle. It says B is your right angle. So it doesn't matter where you write the A or the C. So I'm going to put the A here and then the C here. So here's my right triangle. It tells us that you calculated sine of A, so they're telling us what to use as the reference angle. A is my reference angle. So the sine of A is 5 over 13. What is sine defined as? Sine is defined as, we wrote it up here, opposite over hypotenuse. So I know that 5 has to be my opposite side, and the hypotenuse is 13. So directly across angle A should be the 5, because that's my opposite, and the hypotenuse across the 90-degree angle should be 13. So from here, I can take a look at my 4 possible choices, and they kind of tell me what this third missing side is, AB. Notice that there's a 12 here. So where do they get the value 12? 5, 12, 13 is a Pythagorean triple. You could have already had that memorized so that you could quickly fill in the 12, or you could use Pythagorean theorem in order to find that 12. So if I look at answer choice A and B, notice that these are using the exact same reference angle. They're saying use reference angle A. So is cosine of A 12 over 13? What is cosine defined as? Cosine is adjacent over hypotenuse. Is the adjacent 12 and is the hypotenuse 13? Well, if I look at my picture, 5 is my opposite, right? Hypotenuse is 13, and therefore the adjacent is 12. So 12 over 13, that is true. That's my adjacent over hypotenuse. So A is true. Part B is tangent 12 over 5. Tangent is defined as opposite over adjacent. The opposite is definitely not the 12, so this would be false. For the next two, it's a little bit tricky in the fact that they're not using the same reference angle. They changed the reference angle to angle C. So in fact, I'm going to redraw the original right triangle, and I'm changing this reference angle now to angle C. The 5, the 12, and the 13 are in the exact same spot, but if I change my reference angle to angle C, 12 is now my opposite. The hypotenuse always stays the same, has to be the longest side, but my 5 is now my adjacent. So if I look at answer choice C, it's asking, is the cosine of angle C 5 over 13? Cosine, again, is adjacent over hypotenuse. So in this picture, the adjacent, in this one, the adjacent is 5, hypotenuse is 13. So that's true. Lastly, the tangent is defined as opposite over adjacent. Is the opposite 5 and the adjacent 12? The opposite is not 5 in this picture, so that would be false. For this very last example, they're asking us which of these operations could you type into a calculator in order to find the missing reference angle, which they said is angle A. So our reference angle, unlike the previous number 4, the reference angle does not change at all, so it's always going to be angle A. So the first thing I'm going to do is I notice that we have a missing side length. AB is missing, but if you know your Pythagorean triples, 3, 4, 5, you would know that the missing side length is 3, or you can kind of check the answer key and see that the 3's were there. So let's take a look and label our O, our H, and our A in relation to the reference angle. So directly across angle A is my opposite, so 4 is your opposite. The longest side of the right triangle is always your hypotenuse, so 5 is your hypotenuse, and therefore 3 is your adjacent. So let's see which of these is true. Tangent inverse of 4/5. By the way, remember how to type this in. You would do 4 divided by 5 equals, and then you would hit second tangent in order to get the reference angle. So tangent is defined as opposite over adjacent. So in this picture, is the opposite 4 and the adjacent 5? And the answer is no. For part B, is sine inverse of 4/5. Could that be used to find the reference angle? Well, let's check. Sine is defined as opposite over hypotenuse. The opposite is 4. The hypotenuse is 5, so this is actually true. Third part, cosine. Cosine is adjacent over hypotenuse. Is the adjacent 3 and the hypotenuse 5? And the answer is yes. Lastly, tangent. Tangent is opposite over adjacent. Is the opposite 4 and the adjacent 3? And again, the answer is yes. So that means if I type in answer choice B, C, and D into a calculator, I should get the exact same answer. So for part B, if I type in 4 divided by 5 equals and then hit second sign, I should get the same answer as if I type in 3 divided by 5, hit equals, second cosine, and that should be the same answer as answer choice D, 4 divided by 3 equals second tangent. So I'm going to type in part B here, 4 divided by 5 equals second sine, and I get 53.1 degrees. And then you could check the other two. 3 divided by 5 equals second cosine. I get the same answer, 53.1 degrees. And then answer choice D, 4 divided by 3 equals second tangent, and I get the exact same reference angle, which is 53.1 degrees.